Hello, everyone, and welcome back to class. I'm Dr. Dax, and we are let me try that again. Rewind. I'm Dr. Dax, and we're in infrastructure hardware. I can't pronounce it, but I can teach it. We're in week 6 now, lecture 2, and I hope everybody out there is having a great day so far, and that you've had an opportunity to view lecture 1 this week. And if not, go back and check that one out, and we will pick up here. So I hope that everyone has had an opportunity to get up to deliverable 3 or 4 by now, and we've got about 36 days left in the class, so you should be a little over halfway through. There are 7 deliverables total, and so we are looking for some more content from a couple of you. And the stuff that is coming in, I have a couple of notes that I want to get into. Today is a little bit different because I'm going to hit on a couple of tips that you can use in your presentations and papers, and then we'll dig into the content. And however far we get, that's how far we get. So I'm not going to try to finish the whole slideshow today, but I will. It is uploaded, actually. I did that ahead of time, and you can peruse the notes at your leisure. So, all right. Without further ado, I invite you to sit with me, grab your favorite beverage, in my case, a glass of tea, and let's get the show on the road. Okay. All right. Now, the first thing I want to cover real quick is on PowerPoint presentations. Some of the deliverables will expressly say write a paper 3 to 5 pages, and some will say we want a PowerPoint. And some are sort of ambiguous, like you could do it either way. And in the cases where it doesn't say specifically to do it a certain way, I'm fine either way, as long as you hit all the points of the rubric. Read the instructions all the way through, read the rubric all the way through, because the rubric will have 4 or 5 points usually, and it'll tell you exactly what to look for, and it's going to dictate how your grade comes out. So remember that if you get everything on the rubric done, then your grade should come out all right. If you hit everything except one part of the rubric, you miss one thing, that part gets an F or an I for incomplete. Either way, it's 0 points, and that affects your whole grade for that whole assignment. That's how CBE classes work. Those assignments will be set up so that the grade is as good as the lowest scoring component of the rubric. Okay, so with that in mind, let me show you something I want to do first. Let's talk about PowerPoint presentations. Here's the thing with PowerPoints. A lot of times people put really good notes on the slides. There are good graphics, charts, images that go well with the content, and people have followed my advice as far as hitting 3 or 4 good points and no more. But we do still need the detail. You still need to flesh out your content, but don't put it all on the slide, because that makes the print about this big and I have to zoom in and try to see it with my older eyes. So what we want to do is keep the slides clean with good readable content and use lecture notes. And I'm going to open up PowerPoint real quick and just show you what that means, because I think some people aren't fully aware of it. So let's say you are writing a slide like this one here, and you got your several points. This one's a little bit wordy, but if you want to put additional content, go to the bottom where the lecture notes take place, and you can grab that little line underneath the slide, drag it up, and you've got all kinds of room to write notes. That's where your details will go, and that's how you can explain your points and go into the minutia of the detail. Don't crowd the screen with a ton of content there, and don't just hit a few points and hope that that's enough information. We do want the detail. We do want you to show that you've done the research and you understand the content. So keep that in mind when you are doing PowerPoints. The other note that I've got this week, and I want to bring it up just because I've seen it a couple of times, and sometimes I talk about this in the first week, but for whatever reason, there's always some people that kind of miss that. So when you're writing an actual paper, okay, and you cite facts that people don't ordinarily know, you need to have the proper citation. Let's talk about APA for just a second. Let me open up Word real quick. All right, so let's say you're in Word or whatever word processing program you're using. and you're writing your content. And first of all, you need a title page. Do your title page. Not everybody's doing that. A title page will have your name, my name, the class name, and the date, the name of your assignment, and then do a new line, which is here. You insert and page break, boom, that brings you down to the next page. So let's say you've already got your title page. And my big beef right now is the in-text citations. If you state something that everybody knows, then you don't have to have a reference. So if you're just stating a fact, Star Wars is a science fiction fantasy film. That's pretty widely known. If we say something a little more specific that requires citation, film written and directed by George Lucas in 1977. Now you need a citation. You'll have some kind of a citation. And let's say we got that information off of a website, and the name of the author was Jones, and it was written in 2020. So that's an article on a website. I'm just making this up. All right, so you can fill it in manually like that, or you have the option of using the built-in feature in Word. So go across to References. There's a tab right there. And about halfway across, you see Manage Sources, and the style, it should be on APA. So if it's not, just do the drop down, click APA, and click Insert Citation. So let's say we're going to add a new source. Click that, and it pulls up an option here for lots of things. You can open up that drop down and slide all around and get the article that you need. This is, we'll just say from a website. The author's name was Jones B. You only have to give the first initial. And the name of the web page is, I'm just making this up, Cool Movies. And the name of the website is going to be coolmovies.com. And let's say the year, it was written in 2020. And if you don't have the month and date, that's okay. You leave that blank. And the URL is, you're going to put the HTTPS and then the site. Really cool movies.com/ that's it, Star Wars. Okay. So I made all that up, but here it entered when I clicked OK, the last name and the year automatically for us. That's how you do an in-text citation. So you write the whole body of the paper, and let's say you've done your whole paper, 3 to 5 pages, and you're ready to insert the reference list. And if you go up here under Manage Sources, there's bibliography at the bottom. Click bibliography, and then drag down here to references. You're going to go, just click that one time, and it'll automatically format how the references should look. And if you have 100 references, it's going to alphabetize them and have them under the correct indents and everything. So Word handles all this for you. You got to do it. So make sure you are using references and setting that up properly. And if you have any questions about APA citation or anything else, let me know. I can point you to some really good resources and get you on your way. All right, and that's all I had for notes. Let's go ahead and dig into today's material. Today we're talking about keeping the IT business alive in the event of some catastrophic event. Let me get that pulled up here. And it's all about business continuity. And business continuity is of really big importance for us in this industry because of the sensitive nature of the devices we maintain, the hardware, and the electronics. There are sometimes major failures that can impact the outcome of our data centers and affect lots of customers. So we have to have a plan in place, and it's all about business continuity. So let's talk about what that means. Business continuity in the context of the IT industry is about planning a more comprehensive approach to provide guidance so that the organization can continue to make sales and collect revenue. That's the business school definition. Business continuity is primarily concerned with the processes, policies, and methods that make the organization follow and minimize the impact of a system failure, a network failure, or the failure of any key component needed for the operation. Essentially, whatever it takes to ensure that the business continues. So we've talked about disaster recovery planning before. This is very similar. It covers the natural and man-made disasters, and it tries to ensure that we're able to maintain control and business continuity with our users in the event of something horrible happening. Utilities, high availability, backups, and fault tolerance are all key components to business continuity. When we're talking about utilities, that encompasses everything of electricity, water, mail, gas, all the essential aspects of our facility operation. So when possible, we need to include fallback measures that allow for the interruption of these services. In the vast majority of cases, electricity and water are restored, at least on an emergency basis, fairly rapidly. Disasters like major earthquakes or hurricanes can overwhelm utility companies and government agencies, and services may be interrupted for an extended period of time because they can't get to your facility. First, they're going to handle hospitals and the more critical places. Critical infrastructure for the IT sector might be unavailable for days or weeks or even months, depending on the situation. So what we want to do from the outset is to build infrastructures that do not have single points of failure or connection. So we fight that with redundancies, and we'll talk about that. So as an administrator, it's possible to prepare for most things, but not possible to prepare for every single potential disaster. But you can look ahead to those that can conceivably happen. And that's what we're talking about today. We want to ensure high availability. Now, high availability refers to keeping services and systems functional during an outage. With high availability, the goal here is 99.999% operation, known as the 5 nines availability. High availability and fault tolerance refer to implementing mechanisms such as a redundancy array of independent disks. We've talked about the various configurations of the RAID array, fault tolerant services, clustered services, and similar architectures, which could help to ensure that the business will continue to operate when a system failure can occur. Implementing fault tolerant systems and redundant technologies and performing regular backups of your servers are all solutions that ensure high availability systems. So let's take a look at redundancy. Now, here we're showing server clustering in a networked environment. Remember that redundancy refers to systems or other structures that are duplicated or that fail over to other systems in the event of a malfunction. In other words, if you got a system like this one where the servers are all in a ring and one path is broken, the customers are none the wiser because the flow is on a transmit and receive, and we have an algorithm that tells the server to send it the other direction and passes through back to that server. So failover process refers to when a system that is developing a malfunction automatically switches processes to another system to continue operations. Clustering is the process of providing failover capabilities for several servers working together. A cluster will consist of several servers providing the same services. If one server in the cluster fails, the other servers will continue to operate. Clustering is a form of server redundancy. It might be necessary to set up redundant servers so that the business can still function in the event of hardware or software failure. A simple equipment failure might result in days of downtime as the problem is repaired. A single point of failure is any piece of equipment that can bring your whole operation to a grinding halt if it stops working. Neglecting single points of failure can prove disastrous. In the data centers where I work, we do have single point of failure equipment. I would classify it that way. Things like the sync clock. Now, the sync clock, or the timing, is a cesium clock that syncs up with a GPS clock offsite, obviously. And if it fails and there's no redundancy, then everything in that office that revolves around that particular timing clock is not going to work. It just simply will not sync up. So in disaster recovery planning, you might need to consider redundant connections between branches or sites. Because the records must be available between offices, this is a single point of failure that requires redundancy. If all your business is web-based, to provide continued customer access, it is a good idea to have some ISP redundancy in the event of an internet connection that fails. It costs more on the front end, but it's well worth it if there is a point of failure on your offline server. If the majority of your business is telephone based, you might want to look for redundancy as opposed to the ISP. So you can see in this cluster here, each system has its own data storage and data processing capabilities. And the system that is connected to the network has the additional task of managing communications between the cluster and its users. Many clustering systems allow the sharing of a single disk system. When we're talking about fault tolerance, what that refers to is the ability of a system to sustain operations in the event of a component failure. It ensures that you have the required number of components plus one extra to plug into the system in case of a failure. It can be built into a server by adding a second power supply, second CPU, and other key components. In the multiplexers that I work, it works in the form of M1 and M2. There's two system cards that each have a pair of fibers transmit and receive. So if one system fails, either the card fails or the slot goes bad or the fiber feeding it gets cut, then the other side picks up the workload. There's also 7 T1 cards, which have 4 T1s on each one of them, and then an 8th card that is the protect card. It's the one not in use, and if one of the cards fails and we lose 4 T1s, instead of having 4 T1s worth of service go down, it goes straight to the protect card. And so that's another example of redundancy in a fault tolerant system. All right, Tandem, Status, and HP are all involved in a fault tolerant implementation where everything is N+1 and multiple computers are used to provide 100% availability of a single server. The redundancy strategy N+1 simply means that you have the number of components that you need plus one, and that's the protect we were talking about. So it's imperative in that situation that fault tolerance be built into your electrical power supply infrastructure as well. So at a bare minimum, have a UPS ready and provide surge protection in the event that the power goes down. We've got that on our computer systems and also backup generators. The UPS protects computers from power loss due to power outages. It contains a battery that keeps the computer running during a power sag or power outage, and it gives the user time to save any unsaved data when a power outage does occur. In an online UPS, the computer is always running off of battery power, and the battery is continuously being recharged. So there is no switchover time, and these supplies generally provide the best isolation from power line problems. An offline or a standby UPS usually derives power directly from the power line until power fails. And ferro-resonant units operate in the same way as a standby unit. However, they are online with the exception that a ferro-resonant transformer is used to filter the output. The transformer is designed to hold the energy long enough to cover the time between switching from the line power over to the battery power and effectively eliminates the transfer time. Backup power can be done through the use of a generator. A generator can be used for rolling blackouts, emergency blackouts, or electrical problems. A backup generator will provide power for a limited time. It runs on gasoline or diesel to generate electricity. Brownouts are short-term decreases in voltage levels triggered by faults in the utility provider's system. To protect your environment from damaging fluctuations in power, always connect your sensitive electronic equipment to power conditioners, surge protectors, and a UPS. And that way you can provide the best protection for all. Also, implement the RAID. The RAID system we've been talking about, we'll review that here. Remember, RAID 0 is striping. Okay, RAID enables a group or an array of disks to act as a single hard disk. RAID 0 stores files in a stripe, which basically amounts to small blocks of data that are written across the disks in an array. Parts of a large file might be stored on every disk in a RAID 0 array. Now, in RAID 1 or mirror array, let's talk about RAID 0 first. RAID 0 provides no fault tolerance. If any drive fails, the entire disk space comes up as unavailable. If a drive and the disk striping volume fails, then the data is lost. RAID 1 includes both disk mirroring and disk duplexing. With disk mirroring, both of the disks are connected to a hard disk controller, and a complete copy of the file is stored on each disk. That way, when disk fails, you still have a backup copy on the other. Disk duplexing, which is similar to disk mirroring, uses a separate hard disk controller for each hard disk. RAID 1 provides full redundancy, and if either drive fails, the data can be retrieved from the remaining drive. All that data is stored on both disks, which means that when one disk fails, the other disk continues to operate. This allows you to replace the failed disk without interrupting the business operation. The solution requires a minimum of 2 disks and offers 100% redundancy. The RAID 1 disk usage is 50%, and the other 50% is redundancy. So the downfall is that you can only use half of it for unique content. In RAID 3, we are using disk striping with a parity disk. It uses RAID 0 with a separate disk that stores parity information. So when a disk in the array fails, the system can continue to operate while the failed disk is being removed. Parity information is basically a value that is based on the value of the specific data stored in each disk. In RAID 5, that is referred to as disk striping with parity across multiple disks. RAID 5 also stores files in the disk stripes, but one stripe is for parity, and that provides fault tolerance. The parity information is stored on a drive separate from its data, so that in the event of a single drive failure, information on the functioning disks can be used to reconstruct the data from the failed disk. And RAID 5 requires the least of the 3 hard disks because typically it uses 5 to 7 disks. The maximum number that's supported is 32. So disaster recovery is depending on backups. Backups are duplicate copies of key information. One important method of ensuring business continuity is to back up mission critical servers on the data. Computer records are usually backed up using a backup program, backup systems, and backup procedures. Sometimes it is done locally, and then the backup is stored on a disk or hard drive or even tapes, and then stored offsite somewhere. Data should be backed up regularly, and you should store a copy offsite. There are several types of storage mechanisms available for storage. Working copies, which is also referred to as shadow copies. They're partial or full backups that are stored at the computer center for immediate use in recovering a system or lost file if necessary. On-site storage refers to a location on the site of the computer center in which the company uses to store data locally. On-site storage containers are used to store backup media. And these on-site storage containers are classified according to fire, moisture, and pressure resistance. Off-site storage, as the name implies, it refers to a location away from the computer center where backup media are kept. It can be as simple as keeping a copy in another facility in the city. The storage facility should be bonded, insured, and inspected on a regular basis to ensure that all storage procedures are being followed. And it can also use a commercial offsite storage. Most offsite storage facilities charge based on the amount of space that you require, the frequency of access, and the need of stored information. In disaster recovery, you want to make sure that the company has a disaster recovery plan. The disaster recovery plan is something in writing that defines exactly what steps will be taken in the event of a disaster and how to restore business with minimum delay. It is basically a contingency plan that is based upon company policy, local laws, historic data from previous disasters. And the plan deals with things like site relocation in the event of any kind of emergency or natural disaster, service outage. And as part of the business continuity plan, it mainly focuses on an alternate procedure for processing transactions in the short term. It is carried out when the emergency occurs and immediately following the emergency. The contingency plan would be part of a disaster recovery plan. Understanding backup plan issues. When selecting backup devices and media, you should consider the physical characteristics of that type of drive. There are different drive types to consider. Different considerations include the media type, the capacity, the speed, the rotation scheme, the frequency of backups, and the tape retention time. And the backup time is the amount of time that a tape takes to back up the data. It is based on the speed of the device and the amount of data being backed up. The restoration time is the amount of time a tape takes to restore the data. It is based on the speed of the device, the amount of data being restored, and the type of backups used. The retention time is the amount of time a tape is stored before data is overwritten. The longer the retention time, the more media sets will be needed for backup purposes. A longer retention time will give you more flexibility for restoration. And the life of the tape is the amount of time a tape is used before being destroyed. The life of a tape is based on the amount of time it is used. Most vendors provide an estimate of the backup media life. In database systems, most modern database systems are there to provide the ability to globally backup data or databases and also provide transaction auditing and data recovery capabilities. Transaction or audit files can be stored directly on archival material. In the event of a system outage or data loss, the audit file can be used to roll back the database and update it to the last transactions made. Word processing documents, spreadsheets, and other files are extremely valuable to an organization. By doing regular backup on user systems, you can protect these documents and ensure that they're recovered in the event of a loss. So while the cost of media is fairly cheap, including the user files in a regular backup often is highly recommended. If backups that store only the change files are created, keeping user files safe becomes a relatively less painful process. Although you can back up applications, it's generally considered a waste of backup space because these items don't change often and there's often physical copies of the systems locally available. You should keep single up-to-date versions of it so that it's available for download and reinstallation. So know the backup types. For example, the full backup provides a complete backup of all files on a server or disk, with the end result being a complete archive of the system and the specific time when the backup was performed. The archive attribute is cleared. Because of the amount of data that is backed up, full backups can take a long time to complete. A full backup is often used as a baseline for any backup strategy and most appropriate when using offsite archiving. While the backup is being run, the system should not be used. And in the event of a total loss of data, restoration from a full backup will be faster than other methods. The incremental backup backs up files that have been created or changed since the immediately preceding backup. So regardless of whether the preceding backup was a full backup or not, a differential backup or incremental backup, it resets the archive bit. Incremental backups build upon one another. For example, the second incremental backup contains all the changes made since the first incremental backup. And incremental backups are smaller than full backups and are also the fastest backup type to perform. So when restoring the data, the full backup must be restored first, followed by each incremental backup in the proper order. And we're going to stop right there for now. I hope that this information has been helpful for you, or at least a little bit interesting and a good addendum to your studies in this class. If you have any questions about anything, or you want to hear more about something in general, or you have any technical issues or anything, reach out to me anytime. I can be reached at dax.bradley@rasmussen.edu. You can call or text me at 252-458-7176. And I hope everybody out there has a great rest of the week. And I'll see you next time on week 7. So we're beginning to see we're over the middle hump, and we're seeing light at the end of the tunnel. And some of you may be hoping it's not a train. It's not. We're fine. Everything is great. And look forward to seeing more deliverable content flow in. And if you guys need anything, shoot me a message. We'll see you next time. Dr. Dax, out.